Make sure you've picked up a note sheet and you're going to begin working on Newton's first law screencast. What is Newton's first law? Newton's first law states that an object at rest will stay at rest and an object in motion will stay in motion unless acted upon by an outside force. What is inertia? Newton's first law is also called the law of inertia. Inertia is the tendency of an object to resist a change in motion. It's the resistance of an object to change its current motion. In other words, objects tend to keep doing what they are already doing unless an outside force causes it to change its motion. This applies to both moving and stationary objects. The more mass an object has, the more inertia it has.
Did you know that physics is about how things move and why things move? It was Isaac Newton who discovered the three laws of motion. He was a scientist who lived from 1642 to 1727. Let's first learn about the first law of motion. It is also called the law of inertia. It states objects will remain at rest or in uniform motion in a straight line unless acted upon by an external unbalanced force. To understand Newton's first law completely, we need to learn about inertia first. See, this is a very large sofa. What's special about it? It's stable. It is not moving. Now go ahead and try to move it. Oh, you can't. It's not willing to move. You can't move it as it is very large. Now try to move this small stone. Good. You can move it a little bit, but you had to put in a lot of effort. It was also like it didn't want to move from its original position. Even the smaller things don't want to change their positions. They don't want to move. Even a small stone takes some effort to move. This is the first rule of physics. Things like to stay where they are. No object in this universe would start moving unless some external effort is put on it. It's like all things in the world are lazy. Now, the question is, if things are lazy and they don't want to move, then how does the movement happen? The answer is that there are so many things in the universe which push and pull other things and force them to shift their positions, like you force the small stone to move. But as we said earlier, that things are lazy, they would try and stop their movement as soon as the effort was removed. Well, you'll be wrong if you think like that. You'd find it very strange to accept that when a small stone was still, it wanted to stay still. And once you'd put it in motion after putting some effort, it would like to keep on moving. In reality, it would keep on moving forever and ever. But somehow it stops. But it stops not because it wants to stop. It stops moving because things in its path force it to stop. It may be due to air, or if it bumps into a tree or rough surface on the ground. But suppose there were no tree in its way, or there was no roughness on the surface, and also imagine that it does not have poles or trees in its way. The stone would never stop. It would keep on moving. It happens in outer space, where there's no air or roughness. If you kick a small stone, it'd keep on moving and would never stop. So how can we say that things are lazy? See, the small stone wanted to move forever, but it was stopped by the resistance of air, trees, or roughness of surface. It's like you moving on a slippery road. You'd keep on moving unless there was some effort put in to stop you. The same is true with the small stone in outer space. It would keep moving, as nothing came in its way. It also doesn't want to stop as it is too lazy to do that. So now we can change the first rule of physics. Things want to stay in the position they are, to things want to keep doing what they are already doing. If things are at rest, they want to stay at rest. And if things are moving, they want to keep moving. In other words, things are lazy. So there's a lot of laziness in the universe. Physicists have a special name for this laziness. It is known as inertia. So now you understand Newton's first law of motion. Can you write it? Well, you are very much right.
Let's take a look at some examples and try to explain how they are examples of Newton's first law. These are similar to types of questions that you might see on the test. So for Newton's first law, things we want to make sure we talk about: what does the motion look like? Is anything at rest? Will it stay at rest? Will it be hard to come to rest? Inertia. And outside force. Those are key words to use when we're talking about Newton's first law. So let's take a look at our first example, a car braking. Have you ever felt like you were moving forward when a car brakes and comes to a sudden stop? Even though the car is coming to a stop due to an unbalanced outside force working on it. So the car experiences an outside force causing it to stop, but there is no force acting on the rider in the car. With no force acting on the rider continues to do what they were already doing. The person's inertia causes them to continue their current motion, moving forward, in this case, until a force stops the person from moving. In a car, the seatbelt is the force that stops the person from continuing their movement forward. Example 2, hitting a bump on a bike. Similar is when a person hits a bump or a rock while biking. The bike comes to a stop, but the person lurches forward. The bike experiences an outside force from the rock or from the bump, but the person does not. Because of the person's inertia, the person's resistance to a change in motion, the person continues to move forward while the bike gets stopped. So because of the person's inertia, their resistance to a change in motion, the person continues their motion of moving forward. All right, and let's take a look at the last example. Remember that the more mass an object has, the more inertia it has. For example, if an elephant sits in a wagon and a mouse sits in a different wagon, the outside force on the elephant wagon will need to be stronger to get the wagon moving from rest than the mouse wagon. So just a reminder that more mass equals more inertia. So the elephant wagon will require a stronger outside force than the mouse wagon because the elephant wagon has more inertia because it has more mass. It is also true to say that once the elephant wagon is moving, it will also require a stronger outside force to stop the wagon because of the amount of inertia the elephant wagon has due to its large mass. All right, so now you get to do Newton's first law lab. You're looking to do this in a group of 2 to 4 people. Make sure you have your completed notes because you'll be asked to record what you're thinking. Okay, you're going to have to record how you believe that it's related to Newton's first law, similar to what we just did, using those keywords motion, rest, inertia, and outside force. You're going to need some lab materials, so ask a teacher to bring them by when your group is ready. Complete all the parts of the lab. Check the answer key up front to see how your answers compare. And then keep your notes in your lab so that you can use them on the test. Return the lab supplies to the teacher, and you can pick up Newton's second law notes to watch the screencast if you still have time. Newton's second law screencast is on Schoology in the Newton's Laws folder. Fill out the paper notes while watching the video. Keep for use on the test, and tomorrow you can complete Newton's second law lab. What homework do you have? Make sure you've completed the Newton's first law assignments. If you want to minimize the chance of having homework over the weekend, you can watch Newton's second law screencast at home, but make sure you pick up a note sheet before you leave.